Here we go, example 1. Given f of x is 3x plus 11, and here's g of x, find f of 5. So what this means is we're going to put in 5 for x. So we're going to say f of 5 is 3 times 5 plus 11. When you do this, you get 15 plus 11 is 26. Next one, we're going to do g of 5. So g of 5 is going to be equal to negative 5 squared plus 2 like this. What you want to do is you want to look at the equation, replace the x with a set of brackets, and then you put the number into that bracket, and then you follow BEDMAS to get this. So I'm going to leave this here. I'm going to write the answer to this, which is 25. So it's negative 25 plus 2 gives you negative 23. Now, what's nice about this video is you can listen to how I'm about to say this. This is g of f of negative 4. Don't let it scare you. You're going to say, well, the inner part is f of negative 4. So let's not go all next level here. Let's just find what f of negative 4 is. So f of negative 4 is 3 times negative 4 plus 11. That gives you negative 12 plus 11 is negative 1. So now instead of saying g of f of negative 4, I'm going to say g of whatever that is, and that is negative 1. So because f of negative 4 is negative 1, I'm going to go ahead and follow the instruction given here, and that now is to find g of negative 1, which is going to be negative 1 squared plus 2. Okay, so negative 1 squared is positive 1. We copy down our answer, so that's going to be positive 1, but there's still a negative there, and then plus 2. So when we do that, we get the overall answer here is going to be g of negative 1 is equal to 1. There's our answer, okay, because it's negative 1 plus 2. Now, this looks super confusing. It says f of negative 4. But let's break it down. Wait, f of negative 4, we just did f of negative 4 over here. So I'm just going to draw an arrow here. F of negative 4 is negative 1. So really now, they want us to do f of negative 1, which is 3 times negative 1 plus 11. That gives you negative 3. Negative 3 plus 11 is 8. All right, next example. It says write the equation for the graph below. So I'm going to identify where the zeros are. So the zeros, or the x-intercepts, are 2 and 8. Don't write it as an ordered pair. Next thing, if this is 4, this is 6, halfway in the middle here, that's 5. So the vertex is at 5, 8. Now, what I like to do is I like to practice the last couple letters near the end of the alphabet, X, Y. You don't even need the Z. So this is the X, this is the Y of the vertex. We're going to use that in a minute. I'm going to write down vertex form of this parabola. It's going to be y equals some a value that we don't know yet. If the vertex is at 5 and 8, it would be x minus 5 all squared, and then a plus 8 at the end. Okay? So there's more than one way to do this problem. We could have started in zeros form and put the vertex in. I'm just showing you guys that we can take vertex form, because I think that's what we're almost most comfortable with, and then take one of these nice points. So wait, let's just pick the first one. This point here would be 2, 0. So I'm going to write 2, 0. I'm going to use that as my point I'm going to put in. So the x is 2, the y is 0. So I'm going to go put 0 here. A. X is 2, so I'm going to go 2 minus 5 squared plus 8. Next thing, we got 0 equals A. 2 minus 5 is negative 3. We still have to square it, plus 8. Okay, so I'm going to get 0 equals 9A plus 8. So you're going to get 9A equals negative 8, because we moved the 8 to the other side. And I wrote it down the opposite way around. And then we get A is equal to negative 8 over 9. Okay, so there's our A value. When you want to write your final answer now for the equation, it's y equals negative 8 over 9, x minus 5, all squared, plus 8. Okay, example 3. For the graph of the quadratic function f of x is equal to this, describe in words the transformations relative to the graph of f of x equals x squared. So this, we're going to completely ignore, because it's always going to be transforming from this graph, which is our base quadratic graph that we learned, to this graph. Okay, so the shortcut to doing this is start at the far left and work your way to the right. So at the far left we have this 2. That 2 tells us basically what the step pattern is going to be. The step pattern, if it's a bigger number, it's just going to stretch the quadratic up and up and up. So this is an example. If this is x squared, 3x squared would be taller and skinnier compared to that. Okay? So all you have to write for this is in order if there's any reflection. So if there's a negative sign there, which there isn't in this one, you'd say, first thing you'd say is reflected in the x-axis. But we don't say it for this one. So the first thing we're going to say is stretched vertically. You always say vertically. You're never going to say horizontally in this course. You're going to say stretched vertically by a factor of 2. Then you're going to say, the best thing to say would be translated. And just get this right. This makes the vertex negative 3, negative 8. So instead of the vertex being at 0, 0, we're going to move it left 3, down 8. So translated left 3 and down 8. It says write the coordinates of the vertex. We should have probably done that first. Doesn't matter. Negative 3, negative 8. Write the equation for the axis of symmetry. The axis of symmetry is always x equals, and it's the x value of the vertex, which we just wrote down here. So that's x equals negative 3. Don't just put negative 3, then it will be wrong. It's an equation, so it has to be x or y equals, but it's always going to be x equals for this type of equation. What's the step pattern? I'm going to write down 1, 3, 5. That's not the right answer. This is for a equals 1. When a is equal to 2, it's going to be 2, 6, 10. We just double them all. Okay? Your next thing, you're going to go and graph this now. So you're going to go to negative 3, negative 8. You're going to follow your step pattern. So it's over 1, up 2. I do both sides at the same time. Over 1, up 6, which will conveniently take us to here and here. Now we have the zeros. And we can still go one more step if we want. So we're going to go over 1, up 10. Conveniently right here. And then right here. Okay, so then you're going to want to go like so. And because I'm recording this right now, we all know I'm going to get this wrong somehow. But close enough. Okay, so there's your parabola. I like to put the arrows on the end if you can fit them. That's going to signal to you that, hey, this is slowly going to the right. Just because it's going slowly to the right doesn't mean it stops. It's going to the right forever, and it's going to the left forever. So now when we do our domain, which talks about the x values, they can be any number. So our way of saying that is x is an element of the real numbers. And that's it for your domain. You're going to start the range the same way, except when we talk about the range, we're talking about the y values. So hold on. We go y-er. Now don't get confused because I put dots on here. Those are just key points. Okay, so this, just because there's dots on this graph here, doesn't mean that it's just single points. It's all the points because I've connected this with the line. Okay, so I'm going to put such that if I go along here, the lowest possible I can ever get, the low as it goes is -8, and then it goes up from there. So I'm going to say y has to be bigger than or equal to -8. You always want to start with your y first, then you tell me about it. If it was opening down from -8, we would say y is smaller than or equal to -8. Right now, though, it's opening up, so we say it's bigger than or equal to -8. All right, determine if each relation is a function. So a couple things to remember. Everything's a relation. They're always going to say, determine whether this relation is a function. So what you look for is, are all the x values unique? When you have a list like this, if they repeat the x values, then chances are it's not going to be a function. The only time it would be a function, if you have repeated x values, is instead of 2, 2 and 2, 4, this is not going to be a function because we have two different y values for a single x value. Now, if I would have wrote 2, 2 there and 2, 2 there, that wouldn't really be a problem. It would just be I listed the same point twice by accident. That would still be a function. But if you have to say to yourself, hey, what's my y value when x is 2? And when you answer that question, if you have to use the word or, it's not a function. So when x is 2, y can be 2 or it can be 4. So we know it's not a function. So I'm going to put the word not here. 2, 12, 4, 9, 5, 6, 8, 3. We're good here. All of the x values are only listed once, and they all have y values, so that's fine. So this one is -2, -4, -6. Oh, I see two -4s, and they have different y values, so not. Guys, what I'll do is I'll circle the fact that we have a 2 here and a 2 here. This signals that it's not.
But why?
Okay, so this one's not because of the -4 and the -4. Okay, this one 5, 10, oh, 2 10s. So we're going to say not. The next one, this is a mapping diagram. This tells us that for our x values here, the x value of 6 has two y values. So automatically not a function because this single x value has more than one y value. This one only has one, but this one already ruined it for us. And at the end of the day, this one did too. So this one's definitely not. But it only takes one thing to ruin it. So it's not a function. This one here, look at your x values. They go from -3 to +3. They're only all written once, so we're good. This one is. Okay. The next thing here, you have to remember a little bit of, okay, this one here looks like y equals mx plus b. You don't care what the m and the b are. You just know it kind of follows that format. The other thing we can look for here, I'm going to take apart this 4x for a minute. There's an implied 1 right here. That means x to the exponent 1. If If it's y equals and you have an x to the exponent 1, the 1 would say it is linear. Now, this has an implied 1 as well, but this whole bracket is squared. And also, this is in vertex form of a quadratic. So if that's vertex form, it's a quadratic. So you're just going to say quadratic. And then this one, you're going to look at the exponent. It's not a 2. If it was a 2, it'd be quadratic. The fact that it's not a 2 and it's not a 1 means it's neither. It actually means it's cubic, but we don't study that, so it doesn't matter. So we're going to say neither. Okay, next thing. Blah, blah, blah. This is how you read this question. It says on Mars, and then you go straight to the equation and write it down. So it says d of t is equal to negative 1.9 t squared. Then you go back and you say, well, t is time in seconds, and d is distance in meters. So they want to know how far does an object fall in 4 seconds. That means we have the t, we're going to put 4 in for t. d of 4 is equal to negative 1.9 times 4 squared. So we get d of 4 is equal to negative 1.9 times 16. We get d of 4 is equal to, what is that, anybody? Negative 30.4. Now, even if you don't know how to do the next question, this is actually helpful. So this means, well, it fell 30.4 meters. That's our final answer. It fell 30.4 meters. Now, notice fell, and notice it's negative 30.4 as an answer. So the next question is going to say, how long did it take to fall 90 meters? And that's going to tell us that we have to put in negative 90 when we do the next question. So we get here. Like I said, how long would it take for the object to fall 90 meters? So you're going to write down your formula. d of t is equal to negative 1.9 t squared. So fall 90 meters says to me negative 90. Where do I put that? I don't put it for time. I could do guess and check for the time until I get an answer of negative 90, but that would be really, really messed up. So I'm going to replace this whole thing, not just the d, not the whole thing, and I'm going to put a negative 90 there. Just like if that was just a d. Okay, so that whole thing is negative 90. There's no t left there anymore. The t is still on the right-hand side, though. So we get negative 1.9 t squared. We got to do opposite operations to get the t squared by itself and then get the t by itself. So first thing we're going to do is we're going to divide both sides by negative 1.9. And over here you're going to get, well, this just becomes a t squared. And over here you're going to get whatever that is, negative 90 divided by negative 1.9 is 47.368. If you're wondering how many decimal places to leave, usually 4 is fine. I usually write down a few, like 3, but I leave the whole number on my calculator. So it's still on my calculator. I know you can't see. There we go. There it is. Then all I'm going to do is I'm going to take the square root of that answer. Because I want to go, okay, I'm going to write t is equal to the square root of 47.368. And that is, I get 6.88, 6.882. So I'm going to go 6.88 seconds. Okay, so almost 7 seconds. That's it. When we go to the next question, it's basically the same thing. Same number of 90 meters we're falling, but it wants to know how long it would take to follow that distance on Earth, and then what the difference in the two times is. So we have, I'm just going to go ahead and go negative 90 is equal to, the new equation here is negative 4.9 t squared. Then I'm going to go negative 90 over negative 4.9 is equal to t squared. Same as before, I just didn't show the divide both sides by negative 4.9. So we're going to get t squared is equal to, just go 90 divided by 4.9, because the two negatives make a positive anyway. You get 18.367. And then same as before, t is equal to the square root of 18.367. You get t is equal to 4.285, rounds to 4.29 seconds. Okay, last thing to get 100% on this, they want to know how much longer it takes. So 6.88 take away 4.29. We get 2.59 seconds, and we'll say longer. Question, people. So example number 7, they say the area in square centimeters of a circle is given by the function this. Oh, a equals pi r squared. What is the meaning of a of 5 in this context? Well, a of r is this. So a of 5 would just be the area when the radius happens to be 5. We're going to assume centimeters. So we'll say area, or I should have said the area when the radius is 5. We'll put centimeters, even though it doesn't actually say, unless you read that. Alright, now it says find what a of 5 actually is. So you just write a of 5. Remember, we're not going to do anything with this 5 on this side. We're leaving this a of 5. That's equal to pi times 5 squared, which is going to be, what is that going to be? Okay, so yeah, when you put that in your calculator, it's 3.14 times 25, so 78 point what now? 0.5, and we'll put centimeters squared for our units, and we're good to go. Okay. Example number 8, the graph of the function g of x is equal to this, is translated to the left 8 units and translated down 6 units. Okay, first glance, this looks like a really hard problem. However, let's just graph it. And I'm not even going to make you guys graph the whole thing. We're going to graph where is the vertex for this one. It is at 4, 6. So the vertex is right here. And all they do to it is move it left 8 units. And then down 6 units. So it doesn't matter what order you do here. I'm going to move it left 8 first. So if I go left 8, it's going to take me over here. And where am I going to be? I'm going to be at -4. And then I'm going to move it down 6 units to right there. So it's not the easiest problem, but we know the vertex is right there now. So we're going to write down the new equation. Let's call it, doesn't matter what you call it y equals. We know it's going to be a -2 because we didn't change any of the stretch, and I'm not going to change the stretch on you guys on the test here. So it's -2. I'm going to go like this because pretend I don't know what I'm doing. Put an X here, because that's what vertex form looks like. Wait, where is the vertex? It's at right here. -4, 0 is our new vertex. Okay, so I'm going to put a +4 here. I'm going to put a +0 here. That's my new equation. If I wanted to clean it up, I don't need the +0 there. So it's -2 x + 4 all squared. That's the equation. So you just do a little bit of sketching, figure out where the new vertex is, and you're good to go. Here is another one where we have to do some stretches and transformations. So they give us this base function, so we're going to ignore that. It's stretched vertically and then translated 5 units to the left and 20 units down. And then it gives us the y-intercept. Okay, so this is very similar to the other example we did where we had to find the a value, because they don't tell us how much they're stretching it. So we're going to write down what we know. We're going to write down vertex form. It looks like this. A, I don't know, there's a bracket and then there's usually some number here. So wait, we're going to have an X here. If we move it 5 units left, that would mean that the vertex is at -5. So if I want to make something with the X value of the vertex at -5, I'm going to put a +5 here, because it's always opposite for in the bracket. The 20 units down, you can take at face value. That's a -20. There's our equation in vertex form, but it's not complete because we don't have the a value. In order to get the a value, we need to put a number in for y and a number in for x. Once that happens, we only have one thing left to find, and that's a. So we're going to write down the y-intercept. What is it? Y-intercept is 30. So we have to ask ourselves, what's the x value on our y-intercept? Well, it's 0. So it's 0, 30 is our y-intercept. We use that as our alphabetical order, x, y. That's to remind you, first off, that this is x and this is y, and that those are actually going in place of x and y over here. So great, 30 equals a, 0 + 5 squared minus 20. If you were good at mental math and you wanted to simplify this whole thing, I would have jumped straight to 30 equals 25a minus 20. But I'm going to write it all out here. So wait, 30 equals 5, 0 + 5 is 5. Square it, you get 25. So that's a times 25. Do yourself a favor, write that as 25a minus 20. Please don't let me see the following on the test. I know I usually see 1. I get 30 equals 5a, and then I get a equals 6. Because the mistake there would be thinking 25a and 20 happen to be like terms. Well, they're not. So what do? We move the -20 to the other side. So we get 30 plus 20 equals 25a. And then we get 50 equals 25a. And then we get a is equal to 2. Because we go 50 divided by 25 is 2. Now, if you've made the mistake starting in the middle of the page, you're going to have to write your answer over here. So altogether we have y equals 2 x plus 5 squared minus 20. Okay, how are you guys with that? Is that okay? We just got to connect the dots in our brain now at this point, okay? And look at what everything actually means. Okay, we ready for the next one? I can start recording again? I'm still recording. Never mind. Okay, in case I wasn't recording, recap here. This means it opens down because the biggest that y could ever be is -5. Y is always smaller than or equal to -5. So I put a negative sign there. The shape's the same, so 2 goes here. That makes the shape the same. The vertex is at 3, -5, so I put a -3 there and a -5 there. Next one. Vertex is -4, 0, and the y-intercept is 4. We have to come up with an equation for this. So I'm going to write down y equals a x plus 4, because that's a -4, squared, plus 0. I don't need to write the plus 0, I'm just writing it for consistency. Now I'm going to put in the y-intercept, which means the y-intercept is 0, 4. That's your x, that's your y. 4 equals a, 0 plus 4, all squared. So we get 4 equals 16a. A equals 4/16, which is 1/4. Now this time they want an equation. So we're going to write y equals 1/4 x plus 4 all squared. Okay, opens down, so I know there's going to be a negative. Same shape as this, so I know there's going to be an a value of 2. It gives us x-intercepts of 5 and 9. X-intercept form looks like this. I'm going to put a y equals, and I'm going to put, wait, if it's at plus 5, I'm going to put x minus 5. And if it's at plus 9, I'm going to put an x minus 9. And that's it. So this, again, this negative means opening down. Congruent means the same shape as that, so I'm going to put an a value there of that. We got an x minus 5, because when I put that 5 in, I better get 0, because it is one of the zeros, which I do. 5 minus 5, 0, the whole thing's 0. If I put 9 in, 9 minus 9, 0, the whole thing is 0. Now, go over this video again. Pause as you go. Check out each question on your own page. Look at these review problems right here. They are in your textbook. Do them. You don't need to hand them in, but those would be some good practice.